Okay, so in this video, we're going to learn how to factor by grouping. And we have a polynomial here that's already been partially factored. And we will do different types of examples to get to this point. But we're going to start off with finding the binomial that is common to all the terms. And then we factor it out. And then express the result as the product of two terms, okay? Product of the two terms that are on the left. So what we're going to do is we're going to look at this, okay? X plus 5 and x plus 5. You notice that those two binomials are common, okay? So therefore, that is the GCF. So we're going to factor that out, okay? And we're going to factor that out over here. Okay, and since they're both the same, we just need one of them, okay? And then the other terms that are factored out is x squared and plus 3. And those two go in their own set of parentheses. And basically what happens is if I FOIL this out, okay, I will get my original polynomial back, okay? So this would be the answer, okay? It's already been partially factored, so when it's presented like this, we go ahead and write it. We go ahead and factor out their GCF, and then whatever is in front of the parentheses are put in its own set, okay? So technically, this is really the GCF, okay? All right? Okay, so let's look at another example. Okay, so remember, this is my answer for first one. Okay, so here is another example that has been factored, or partially factored. Notice that what's common in all three terms? Well, we have 7y minus 4, 7y minus 4, 7y minus 4. So we're going to take that 7y minus 4 and factor it out. And then now what's left behind is y cubed plus y minus 2. That goes in its own set of parentheses. And there you have it. It is factored. So if I take the product of these two, I will get my original polynomial back. Okay? All right. So and that is a 3 here. Okay? So let's do more examples. Again, what is the common factor? It's going to be k plus 1/4. So we're going to factor that out. And look at the term that's been factored out in front of each parenthesis. You got this and that, right? So that goes into its own set of parentheses. And that is your two factors, okay? So once it's been factored, we just do it just like that to finish it off, right? Okay. Now, what happens when we get a problem that is like this? So now you have a 4-term polynomial. Now we're going to have to start the factoring process, unlike the previous 3 examples. Okay, so we're going to have to take out the GCF, and this is what I call factor by grouping. What I do is I split them down the middle, and then I break them up into 2 groups. Okay, so this is going to be group 1, and over here on the other side is going to be group 2. So now we're going to factor the GCF. We're going to have to take out the GCF. Okay, so here's what we do. All right, so what we're going to do is look at what's common in both sides. So here on the left of this bar that I made is x cubed minus 3x squared. Numerically, we can't factor anything out. There's nothing in common. Okay, so we're not going to be able to factor out any numericals. However, we can factor out an exponent. And what we do is we want to choose the lowest exponent between the 2 terms. So x cubed, and then we have x squared. So x squared is what we're going to factor out. And we're going to factor that out over here. And now we have something left behind. And in order to figure out what you have left behind, think backwards and say, okay, I have x squared. I factor that out. Then you have to say, well, x squared times what gives me x cubed? Well, it has to be x. Okay? And as a little footnote, x squared times x, remember the x has an exponent of 1, and if you multiply, okay, 2 bases, okay, that are the same, the rule of exponents is we add them up. So then you get x to the 3rd power. And that's why I'm just taking out, that's why x is left behind, okay? Minus, well, if I take out the x squared, then I'm left with the 3. 3 stays behind. Then I look it to the right and I repeat the process. What is the GCF? Numerically, 4 is the biggest number that will go into 4 and 12. So we're going to take that out, and you notice that it's a plus 4. Okay, so we look at the sign here, and that's what goes here. All right. So now what's remaining? Well, 4 times what is 4x? The x stays behind because we didn't factor that out. The minus stays, and then 4 times what is 12? Well, it has to be 3. Now look at this, okay? This is the same as this. We're going to factor that out. Okay, so then we have x minus 3, and then of course the x plus 4 goes in its own set of parentheses. And now we just found the product of the 2 factors. So to prove to you that this works, we're going to go ahead and FOIL this out so that you know it's correct. So we're going to FOIL, right? Remember what that stands for? First, outer, inner, last. All right, so here we go. The first thing that we're going to do is that. That is your first. X times x squared is x cubed. Okay? The next thing that we do is take the x and multiply it by 4. And that's going to be your outer. Well, x times 4 is plus 4x. The next thing we're going to do is the inside. Is the inside. Well, minus 3 times x squared is minus 3x squared. And then, of course, we do the last, which is going to be negative 3 times 4, which is, in fact, negative 12. You notice that we got the original polynomial back. X cubed, it's just rearranged differently, but it's the same thing, right? So I can just say, okay, all right, it's going to be the same thing, just a different order. But if you rearrange them, you're going to get the original polynomial back. X cubed minus 3x squared plus 4x minus 12. So it works. Okay? So you can check it if you're doubting yourself. All right? Okay. Let's go ahead and do another one. All right? All right, so we have 2y squared minus 14y minus 5y plus 35. All right, so let's go ahead and split them right down the middle. And let's find the GCF on the left side. Numerically, the most we can take out is a 2. That is the biggest number that will divide into 2 and 14 evenly. Exponentially, we take out the y to the first power because that's the smallest exponent. So we're going to take this out, and then that's just going to be y. You don't really have to write y to the first because it's understood, so I'm just going to write y. And then now we have something remaining. So if I factor out 2y, all right, the 2 is factored out, and then I have y squared, so I took one of the y's out, so that's reduced to just y. Minus, all right, 2 times 7 will give me the 14, and then of course the y has been factored out. Here on the right side, the coefficient is -5, so we have to put that negative here. And now 5 is going to be the biggest number that we're going to factor out. Okay? 5 is the biggest number that we can factor out because 5 is the biggest number that goes into 5 and 35. The y stays behind, plus stays the same. 5 times what is 35? Well, it has to be 7. Okay? And you notice that these two are the same. That's my GCF. So I'm going to factor that out. Just write it once. Okay? Let me make that red so it matches. Okay, and then now the 2y minus 5 in red goes in its own set of parentheses from left to right. And then there you have it. Those are the two factors that if you FOIL or multiply, you will get 2y squared minus 14y minus 5y plus 35. Okay? All right, so let's look at another one. So we're going to split them down the middle, right in between the second and the third term. Okay. And now we're going to find the greatest common factor on the left side. So think of a number that goes into 14 and 35. Think of the biggest number. It has to be the biggest number. And the only thing I can think of is a 7. Okay. So a 7. And then exponentially, I'm going to take out k to the first power. That's the smallest one, so that needs to be factored out. I choose the smallest exponent. All right? Now, 7 times 2 will give me the 14. If I have k squared and take out one of the k's, then one of the k's stays, plus 7 times 5 is going to give me the 35. Okay? Look at the 12. The leading coefficient is negative, so that needs to be factored out. And then the biggest number that goes into 12 and 30 will, in fact, be 6. Okay, so let me make that red. And then everything else stays. So 6 times 2k gives me the 12k. A negative times a positive is the only way to get that negative 30 back. You see that? So a negative times 5, positive 5 gives you a negative 30. So if you have a negative 6, the only way to make that a negative 30 is you have to put a positive 5. That's the only thing that gets multiplied by the negative 6 in order to get that minus 30. So then you have, you look at your GCF, which is 2k plus 5. So we're going to factor that out. And then your 7k minus 6 is your other factor. Okay? Alright, so let's see if we can do... Alright, so that's pretty much how you do factor by grouping, okay? So I hope that this video was helpful, and hopefully that it'll help you, work problems with factor by grouping. Factor by grouping is, I use it a lot to factor trinomials because it's a very methodical method. So you're going to see me doing that in the next video when I factor trinomials. Okay, thank you for watching.